Hello Year 10, welcome back to your next class, living room lessons. I've forgotten what they're called already, that's good. Today we're going to be cracking on with our weather and climate unit, and we're going to be coming on to think about something a little bit different. But what you are going to need today, there's quite a long list today I'm afraid. So you're going to need your exercise book, pen and ruler, some highlighters today would be great, your phone, small world map, so there's a little world map on one of the sheets, print that out, small, you don't need it A4. The comparing climatic zone sheet, which is A4, so you probably do want that quite big. Reasons for climatic zones, you don't need to print that one, that's just have a look at as you're filling it in. And then the reasons for heavy rainfall in an equatorial climate. So lots of stuff today, make sure you've got it all printed and ready to go, all the bits that you're going to need. So before we dive in, as normal, we are going to do our jog your memory. So our 3 questions today: which of the definitions describes convectional rainfall? Which of the following is a driver for globalisation? And define the positive multiplier effect, that word I keep banging on about, all right? So pause your phones, scan the QR code and have a go at this quiz for me. Okay, hopefully you've had a go at that. Before we dive in, let's have our little well-being tip of the day. Read a book. Read many books. Read lots and lots of books. Now is the time for you to actually sit and read a book and really, really enjoy it, not just to fill in your reading log, sorry, English department. Sit down, bury yourself in it, have a great time. It's going to really be a good thing for you to do right now, all right? So let's get started. So what we're doing today is we are going to be comparing different climatic zones. So climatic zones are large-scale areas, places that are affected by a particular type of climate, and we're going to be comparing 2 different climatic zones today. These 2 zones are going to also link in when we come to theme 3 in year 11, when I'm back with you all, when we're having a look at ecosystems. We're going to have a look at the same 2 ecosystems. So in this lesson we're going to have a look at why they have the climate that they have, and then we will come back to have a look at what they're actually like as places in terms of the animals there, the plants there, the people living there. So titles in your book today is comparing climatic zones. Write that in, underline it. Good job. So the first thing I would like you all to do on your little world maps, so those little world maps you've got, I would like us to have a little recap on where we would find them due to the global atmospheric circulation. So ideally with 4 different coloured highlighters on your world map, I would like you to label on where we would expect to find our different climatic zones. So where we're going to find a tropical zone, our equatorial zone, a desert, a hot semi-arid, that's one we haven't really spoken about yet, so you might want to leave that one and we'll talk through it in a moment, and a temperate zone, which is where we are. So just quickly highlight in 4 different colours, make sure you've got a key on there where you would find these for me. Okay, hopefully you better go at that. Let's talk through it quickly together. So our tropical zones, as we know, we are most likely to find along the equator. So our tropical equatorial climatic zones are going to be found at 0 degrees directly along the equator. Our deserts, we're then going to find at about 30 degrees north and south of the equator. So hopefully you shaded in somewhere between your 20 and 40 lines, because that's where we have that falling high pressure. Our hot semi-arid zones, this one's a bit of a trick, are found between these 2. So you would find them between your tropical zones and your desert zones. They're on the periphery of the deserts. And then finally, your temperate zones, you would find at around 60 degrees north and south of the equator. All right, so hopefully you've got those shaded in now, and we're going to move on to have a think about our 2 different zones. So as I said, the purpose of this lesson is we are going to be looking at 2 different climatic zones in-depth detail. So our 2 zones we're looking at are hot semi-arid zones and an equatorial climate. So what you should all have is this sheet printed out. If you weren't able to print it out, draw it as a big table on a whole page in your book, please, okay? So what we're going to do is we're going to go through the definition, where they're found, what the climate is like, and the reasons for the climate in these 4 different places. So, 2 different places. So we're going to have a think about why these 2 different places have very particular climates. So starting off with our hot semi-arid zones, we're going to go through all of the bits on that side first, then we will come on to our equatorial. So as I mentioned, the hot semi-arid climatic zones are these areas of climate which we find on the periphery of deserts, so on the edge of our deserts. They're not hot and dry enough to be deserts, but they're also nowhere near tropical enough to be our equatorial zone. So they're kind of the buffer zone. So they're this transition between the deserts and the tropical climates. So first thing I would like you all to do very quickly is in your definitions box, just copy down our definition of what a hot semi-arid climatic zone is. Pause the video now and copy this into that box for me. Okay, next we're going to have a think about where they are found. So in terms of where we find them, here is our map. So as we can see, they're often known as steppe. It's a bit of an old term for them. We call them our semi-arid zones now. But as we can see quite clearly, it's the grey zones on our map. So it's these areas on the edge of our deserts, so the areas surrounding our deserts. So if you were to describe where these zones are generally found, first thing you probably would have already put in your definition is that they're on the periphery of deserts. But what you could also mention is that they are generally found at around kind of 20 degrees north and south of the equator. We can see quite a few of them 20 degrees north and south. You might also say specifically where they are. So we found them south of the Sahara or to the east of the Simpson Desert. So again, just pause your videos and make notes on where we would find our hot semi-arid climatic zones. Okay, so the next thing we're going to have to think about is, I'm not very stable on my knees, is our, what is the climate actually like? So what climate would we find in these climatic zones? So what you're going to have in a moment to look at is a good old trusty climate graph. You've seen these quite a few times before, but let's quickly recap how to read a climate graph. So along the bottom, we've got these 12 letters. These obviously equate to each month, so January, February, March, etc. Going up our left-hand axis is our temperature, so degrees Celsius. And to measure your degrees Celsius, you are using the red line. Remember, you always use the line to see your temperature. Doesn't matter what colour it is, sometimes they like to really mess with us and swap it around and have a blue line and red bars. Don't know why, but they will sometimes. But it's always the line that measures temperature. And then going up your right-hand axis is the amount of precipitation in millimetre. And this will always be measured in bars. Okay, so the bars always are read on this axis and they will always show the precipitation in that area. Okay, so what I'd like to do now is pause your video, and in the box that says what is the climate like, I want you to write a few sentences or points describing the climate. So you're going to want to talk about, is there a wide range? So is there a huge range in the temperature and rainfall? Not really. Or is there? And then months where there's maybe highs of rainfall. Is the rainfall actually all quite low? And the average kind of temperature, all right? So just take a couple of minutes, pause the video and write a few notes on that. Okay, so this is what your table should look like so far. So definition, regions of predominantly dry weather with short wet seasons. In terms of where they're found on the fringe of our arid zones, transition between the hot deserts and the tropical climates. You could also then put an example, so e.g. south of the Sahara Desert in Africa and west of the Simpson Desert in Australia. When we then come to our climate, which is the thing you've just been having to have a look at from the climate graph, we'd say the average temperature has got quite a little range. It's not got the same kind of large range that we have in a temperate zone. It ranges from 23 degrees Celsius to 27 degrees Celsius. So there's not a huge fluctuation in temperature. They have a low average rainfall with 4 months of the year being below 50 millimetres, which is quite a small amount really. And the most rainfall occurs in April and March. So they did have quite an obvious wet season, an obvious period when there was a lot of rainfall. So what I'd like you to do now is pause your screen and on your computers or whatever, pull up the sheet that says reasons for the climate or something like that. Can't remember what I called it exactly. Reasons for the climate, and you'll have a load of information about why our equatorial climate zones have this particular type of climate. And what I'd like you to do is make some notes in this box here, the reasons for the climate, based on the 4 main factors that affect the climate. So pause the video, take a good 10 minutes to read through it, write some notes, and then I will talk through them with you in a moment. Hopefully you've made some notes, but I am going to talk through our four main factors now, okay? So we come back again to our global atmospheric circulation. This is going to be drilled into your brains by the end. So, as we've said, our hot semi-arid climatic zones are generally found where our Hadley cells and our Ferrel cells are meeting. So it's generally going to be more high pressure in this area. However, there are some periods of low pressure, but it's predominantly going to be high pressure. So it's at this point when our air is sinking again. And as our air is sinking, we know what happens to the air, but you know I'm going to say it again. The air sinks. It goes from a cold place to a hot place. When it goes from being cold to hot, any moisture will be evaporating off, meaning that there's little moisture left in the air, which is why they have a predominantly dry climate. But as I said, they do have these periods of wet season, so it's not always high pressure. They're also often affected by the rain shadow effect, which is all linking together now, isn't it? Which we know from looking at our types of rain. So often they are found further inland. So you're not going to find hot semi-arid climates generally near to the coast. And because they're further inland, often they're being affected by this rain shadow effect, where we have an area of high land, and as the prevailing wind brings moisture in across that area of high land, it's forced to rise rapidly. And as it rises rapidly, it means that lots of the moisture then falls on the top of that high land, which then means that as we then come back down over the mountain, we have high pressure because that air is sinking. So all of the moisture from the sinking air evaporates off, meaning that areas inland of the highland are more likely to have a lack of precipitation. They're also very much so affected by these ocean currents. We haven't spoken about these much yet. So cold ocean currents bring cool, dense air that then moves the warmer air on. So if you've got lots and lots of cold air coming from the sea, cold air is denser than warm air. The particles are much closer together. So it's like a big arm wrestle, okay? So as they come together, the cold air is eventually going to force the warm air to move inland because it's stronger. And as it forces it to move inland, that means that these areas inland, our hot semi-arid zones, are more likely to get more of this warm air with a lack of moisture, okay? Which brings us on to our last point, which is our prevailing winds. So often we find in hot arid areas, the prevailing winds are blowing from the land to the sea. So because they're quite far inland, there's no coastal wind coming in. The wind that there is blowing across the land, which means that these hot semi-arid climatic zones are mainly going to be getting warm, dry air that's blowing from inland. So next we're going to come on to have a look at our equatorial climate zones. Don't worry, I will show you a completed table later on so you can make your notes. But next we're going to have a think about our second climatic zone. So an equatorial climatic zone is very, very different. We obviously find it along the equator. We more likely know these as tropical rainforests, but their official climatic zone is an equatorial zone. So you're on that right-hand column of your table now. So going to skip a little bit here. I'm not going to give you all of the answers on this one. So this is your location and what the climate is like. So on the left, we have got a map showing the location of our equatorial climate zones. And on the right, we have got our climate graph. So I'm going to ask you to pause it again. And I would like you in the location, so where they're found, and what the climate is like, to fill in those two boxes now using these two bits of information. In terms of your definition, really straightforward. All you need to write is climatic zones found along the equator, also known as tropical rainforests. Something very simple like that, okay? So you're going to be filling in those second two boxes, the location and what the climate is like. So pause your screens now and fill those boxes in. Okay, so this is what your table should look like so far. Hopefully you've started to be a bit more comparative on this. So our definition, as I said, very straightforward. Regions along the equator, also known as rainforests, typically areas with lots of rainfall and high temperatures. In terms of your where they are found, hopefully you picked up that we had our lines of latitude on there. So you will have said found along the equator between 30 and 0 degrees north and south of the equator, generally between the tropics of Cancer and the tropics of Capricorn. Then your examples, you could have put Central Africa, northern parts of South America, so the Amazon for example, and Southeast Asia. In terms of our climate, this is where I wanted you to be a little bit more comparative. So we said that our hot semi-arid climatic zone has a small range of temperature, but hopefully you noticed our equatorial climate zone has an even smaller range. So the average temperature has a smaller range of between 26 degrees Celsius and 28 degrees Celsius. So generally their average temperature is fairly stable. It stays pretty much the same every year. Start to link that with what we know about distance tilt of the Earth, and you might start to have to think about why. They have rainfall above 60 millimetres every month and heights of 298 millimetres in March. So whereas we said they have 4 months but they have less than 50 millimetres in our hot semi-arid, in our tropical rainforests, every month has got above 60 millimetres. So every single month they have got more rainfall generally than our hot semi-arid zones, okay? They have real highs, but those highs are fairly consistent. You'll notice that those blue bars were quite high up on all of them. So what you're going to do again now is you're going to have a go filling in this reasons for the climate box, again using that help sheet. There's only 3 on this one, so just make sure these notes are up to date. Have a go at the reasons for the climate, and then I will talk through them again in a moment. So I will talk through these with you now. So here it is again. Yes, I love it. Our global atmospheric circulation. So if we are finding our equatorial zones along the equator, along the centre of the Earth, as we know from our rising air, our rising and falling cells of air, that at the equator is where we have the majority of our rising air. So as that air rises, it's going from a warm place on the surface of the Earth to a colder place as it moves up through the troposphere. And as it moves upwards, any moisture in that air is cooling and condensing to create rain clouds, which is why these areas of climate have massive amounts of rainfall. They have rainfall nearly every day, which we will come back to in a minute. Now, due to the intense heating, we also will find that they have a large amount of our convectional rainfall. So that ground is being constantly heated because it's the part of the Earth that is closest to the sun. So as it's being constantly heated, that then leads to this constant rainfall. And as we get this convectional heavy rainfall, you'll find in tropical rainforests, they have rain daily. And then lastly, I don't know why it says reason 1 and 2, I really messed up there. Reason 3, this is our latitude. So as we know, with our Earth, the Earth is always tilted. And as it's always tilted, the equator is always facing the sun, regardless of whether it's tilted, or the northern hemisphere is tilted towards the sun or away from the sun. So our equator gets the same amount of concentrated sun's rays every day. They don't get seasons along the equator. They have the same amount of rainfall every day, which is why they have so much convectional rainfall, why they have so much intense heat, because the Earth is always tilting in a way that the equator will always be the closest point to the sun. So this is what your finished table should look like. So in your reasons for the climate, the global atmospheric circulation, convectional rainfall, and latitude. So the fact that our latitude is at 0, it's always the closest to the equator, means it's always going to get this intense heating, okay? So I'm just going to get you to pause your screens quickly and make sure that your table looks like this, all right? Okay, nearly at the end today, but I just want us to come back to that idea of convectional rainfall that we spoke about in our equatorial climates. The fact that they always have this intense rainfall on a daily basis because of the ground being heated. So what you are going to be doing is you are going to be writing a bit of a timeline for a day in the life of the equatorial climate zone. So what you should now have is that sheet which says reasons for convectional rainfall or something like that. And on the screen in a moment, oh, well, they're here now, but you'll pause it in a moment, you have got a range of different things that could be happening at different points during the day. What I would like you to do is pause your screens and fill in that sheet, putting these at the correct time of day to show that constant cycle of rainfall that they have on a daily basis within our equatorial climates. Okay, so pause now, read through all of these and write them into the correct part of your sheet. Okay, so last thing is we will talk through our answers on this. So about 6 AM, sun rises at the same time every day because no seasons, same every day. By about 8 a.m, the early morning clear skies, no clouds, very warm, very little wind. By 10 a.m, this hot air rises as the morning progresses. So as the heat starts to build, that air will rise. Water vapour from rivers, swamps, forests, all of that moisture that you find in these zones starts to rise upwards. Till by midday, the sun is directly overhead. It's really hot, averages of 30 degrees Celsius, and there will be small patches of clouds starting to form as that heat has continued to make the moisture rise. By about 2 p.m, your clouds will increase in size and height. So as the afternoon starts to go on, there's lots more clouds forming. We have our huge, I can never say this word, cumulonimbus clouds, our big clouds, those ones that we see which are massive rain clouds. They start to form by early afternoon. By 3 p.m, this is when your rainfall starts. You'll have torrential rainstorms, thunder, lightning, lots and lots of wind. By 4 p.m, the storms continue as afternoon progresses. So these storms will continue throughout the afternoon. The sky is really dark, it's full of thick cloud. By 5 p.m, the storms will start to end, the clouds begin to break up, the winds die down. Until by 6 p.m, the skies are starting to clear, the sun sets at the same time each evening. So that sun goes back down, and by 8 p.m, they have very clear nights, very humid, very hot, and then the cycle begins again. So this happens every single day on in your equatorial climate zones. So the last thing we're going to do, as we seem to be doing, and lots of you have been saying you've been struggling with the exam questions, so please make sure that you are emailing your teachers if you are struggling with these exam questions. Sorry, Miss Charles and Miss Middleditch, you're going to get loads of emails now. But yeah, please email any questions about the exams because it is important that you're having a go at these questions. So your question today is explain the possible social, economic and environmental consequences of a climatic zone you have studied. So I am going to break this down on the board for you today. So this question, it says explain the possible social, economic and environmental consequences of a climatic zone you have studied. So you can just choose one of them. So you could do just hot semi-arid or just equatorial because it says a climatic zone. So what I would do is I would choose one of these. So I'm going to go for our hot semi-arid zones, okay? And it's a 6-mark question. So on your 6-mark question, that means you're either going to be doing 1 long snowball or 2 snowballs. Now I would think because it says explain the possible social, economic and environmental, you're probably going to choose 2 of these. So I'm going to give you a sentence starter. I'm going to give you the points to get you started, and then I want you to have a go at snowballing them. So a social impact in a hot semi-arid zone is drought. Okay, so that's our point made. So with your point, you now need to explain this. So my first explanation would probably be, this is because. And then in this gap here, with my dots, you are going to explain why they would be likely to have droughts. So why is a hot semi-arid zone likely to have droughts? Have a look at your climate graph. Why would we expect there to be droughts? Once you've said why, you will say this means that. And this is where you're then going to link this to the fact you've said it's a social impact. So how are you going to link the fact that there may be droughts to it being a social impact? So that would be your first snowball. So you can use this structure, but make sure you're in your dots explaining that point for me. If we were then going to have a go at a second consequence, we might say that an economic impact would be crop failure. This is due to, and again you're going to explain why, because of our climate, there is going to be crop failure. Then you would have to do your final explanation. This results in, and you need to explain why That's an economic impact. What impact is crop failure going to have on the economy of a place? All right, so have a go at this question in your books. Pause your screen so you've got the question there. You might have to fast forward a few times, rewind, sorry, so you can go through the structure again, because I appreciate it's not that easy to hear on the screen. But have a go, 2 snowballs for me. Right, well done. Hopefully you've got all of that done today. The things you should have in your books today. Highlighted world map of the climatic zones, that little map with your highlight and a key. Make sure there is a key. Oh, end of slideshow apparently. A completed comparing climatic zones sheets, reasons for the heavy rainfall, and your 6-mark answer. If you haven't got all of these things, make sure you go back and have a go at completing all of this in your books. Well done, Year 10. Another great lesson, I'm sure. Keep it up.